Good afternoon, everyone. I'm Vivian from Singapore Water Association. Thank you all for attending today's webinar on fostering water technology partnerships. Today's session is co-organized by Singapore Water Association and EWTCOI Ngee Ann Polytechnic. Before we proceed, I'd like to touch on some housekeeping rules and disclaimer clauses. To ensure a smooth webinar, please mute your microphone and turn off the camera. You may communicate with us after the session. Please share your questions in the chat. We will try to provide answers where possible in the Q&A segment. Do identify yourself so we can respond to any unanswered questions after the webinar. We'll be recording this webinar and reserve the rights to the video. Please complete a post-event survey, which upon return will forward the recording and presentation tag to the respondents. All information in this webinar is for general information only and does not contain or convey any legal advice or administrative assistance. Information shared today is true and accurate as of publication date. SWA and EWTCOI reserve all rights in the provided materials. Today, we are pleased to have Dr. Jason Tang, Director of EWTCOI, to share with us on the multiple supports from EWTCOI. Dr. Jason Tang has been with EWT for more than 10 years. He has been supporting technology development in the area of environment and water technology. We are also pleased to have Mr. Pung Teng, founder of Film-Based Private Limited, to share with us on the development of super hydrophilic water filtration membrane with EWTCOI. Mr. Pung is a founder of Film-Based Private Limited, which started in 2011. Film-Based focuses on the development of opportunities in advanced polymetric materials to meet the growing needs on water, energy, and infrastructure. They have also been advancing on new generation of hydrophilic attendees for polymetric water filtration membranes. Without further ado, may I now invite Dr. Chen Jia Long, Council Member of Singapore Water Association, Deputy Director of EWTCOI, to give us a welcome address. Dr. Chen, please.
Thanks, Vivian. Dr. Jason Tang, Mr. C T Pung, ladies and gentlemen, a very good afternoon. I'm honored to be here to welcome all of you to today's webinar, jointly organized by Singapore Water Association and Environmental Water Technology Center of Innovation. SWA and EWTCOI have been working very closely in the past few years, as we share the same goal to facilitate and support our water industry through market access, networking opportunities, partnership, information and knowledge sharing, and technology consultation and validation. SWA and EWTCOI also work closely with key stakeholders to align with national interests and national directions. In such COVID time, SWA and EWTCOI would like to organize a webinar to explore the multiple support from EWTCOI and to gain a better understanding on how R&D complements water technology deployment. Please allow me to briefly introduce SWA. Started in 2004, SWA has been providing a platform to build effective networking, facilitate opportunities for collaboration, and foster the exchange of ideas and knowledge among member companies. Our mission is to develop a vibrant and dynamic Singapore water industry with the vision to be the regional hub for all water service and technologies. SWA also actively connects to the global water network through setting up Singapore Pavilion and overseas trade show, overseas missions, and business seminars. Our current 258 members now comprise a diverse mix of both local and international organizations commercial companies, research institutions, SME, startup, and also individuals, which cut across the whole water value chain. COVID is significantly impacting our health, lifestyle, business, and the economy. SWA is working closely with our members to help mobilize, stabilize, and resume operation with our SG United Updates, SWA Assist, S-Watch initiative, and also weekly updates. We also launched the SWA Marketplace Assist platform, SWA Map for short, for our members to seek help from other fellow members or partners and facilitate continuing the business. More info can be found from our SWA website, or you can contact my fellow colleagues from SWA to find out more info. SWA is also working with Singapore Business Federation, Enterprise Singapore, Skill Future Singapore, and more in assisting local companies for some job retraining and creation. We all know Singapore has a great reputation as a global innovation water hub, and it was through the leadership from PUB and various support from National Research Foundation and ESG in developing and adopting new technologies. So SWA would like to encourage more of our water companies to take advantage of this strong local R&D ecosystem to develop proprietary and innovative technology and solutions that will make your company and business more competitive and resilient. Today's webinar is one of such opportunities. In closing, I look forward to see some new partnerships sprung up from today's webinar and let SWA and EWTCOI to contribute to your business growth. Last but not least, if you are already SWA members, I would like to thank for your support, and please feel free to let us know how we can serve you better. If you are not SWA member yet, we would like to welcome you to join us this big family. I hope you will enjoy today's webinar. Thanks. Vivian, the floor is yours.
Sorry, Vivian, you're mute.
Apologies. Thank you very much. Thank you, Dr. Chan. May we now invite Dr. Jason Tang to give us the insights on the multiple supports from EWTCOI. Dr. Tang, please.
All right, a very good afternoon to all our participants for the webinar today. In this current situation of the COVID-19 crisis, I think it's a lot of new normals that we have to get accustomed to. And one of the new normals is, of course, conducting webinars as opposed to face-to-face, right? I mean, we do recognize that there are a lot of challenges with meeting face-to-face now, but in the current situation, we have to work through and find the new normal, as we have been hearing quite often. Now, I won't go so much into the detail as to what capabilities we have, because I think nothing speaks better than talking about the projects. But nonetheless, I thought that it's still good to go through some of the details for those of you that are not so familiar with the EWTCOI, right? One of the things that you may not know about us is that we have been around since 2006. So we have had roughly about 14 years of experience engaging with industry. And you can imagine we do face all kinds of requests from clients. And with some of the requests came to us even on a napkin, right? Very, very similar to what you hear about inventors coming up or having coffee with their friends and then they just draft out an idea on a napkin. That idea came to us in one of the clients that we met in the past. And we've had all sorts of projects from all different walks of life, from startups to MNCs. So I'm just giving you an idea that we don't limit ourselves to the companies that we engage. In fact, we are able to work with all companies, not just the local companies, including overseas companies, if there are any overseas partners over here today. Right, so aside from the collaboration, we do have certain fundamental capabilities. Now, I won't tell you what they are, it's all on the screen. I know it's a little small, so if you're using a small laptop like mine, it might be a bit hard to read. But suffice to say that we do cover all aspects of engineering, right? And myself, I'm actually biomedically trained. So I do bring a different set of expertise into the whole mix, right? And it's the same for Dr. Chen. He's also a microbiological trained, although it's on environmental microbiology, right? So we do come from an eclectic mix of different engineering disciplines. And in the current climate of innovation, this is actually quite beneficial, right? Because when you talk to people like PUB tells you about the water, the waste, and the energy nexus. Now, all these three covers very different disciplines. And if you talk to a water engineer about energy, they may not be able to advise you how to save energy, right? It's the same, you talk to an energy engineer, they can't tell you how to treat the water, right? So you need a nice mix of people. And when they come together, you can put forth a very holistic solution for industry. Now, the next slide, you will see a little bit of the facts, and some of you may be quite familiar with this, as this may have been flashed in a few events before. It's really just to give an idea of the current status of how big we are. Some people ask, are we a school? No, we are not a teaching school. We are actually a 100% industry-facing business unit, right? So we are fully engaged on consultancy projects 100% of the time. So this frees up possibilities for us to work on all kinds of different types of projects. And we do have quite a fair number of know-hows and trade secrets, because as you can imagine, every company wants to have something proprietary, something that makes them stand out from the crowd, right? So we do have a lot of that, and some of which we of course can't say, but there are others where we are able to share with you. So a lot of the statements that we hear from our clients comprise of some of what you may see on the screen, right? Some of them may be on energy efficiency. Can I make my pumps work more energy efficient? And you will hear a project later where we managed to do just that. And can we also look at generating revenue from the technology that either COI may be putting out, or could I develop my own IP, right? And IP here stands for intellectual property. So without ado, I will just jump straight into one of the projects that we have with a local company. Now, we initially started this idea of treating water for the F&B, partly because, first of all, we are all foodies, right? So I love noodles and I also eat tofu. Now, the process of making noodles and tofu wastes a lot of water. And the problem with this is a lot of the water is a single pass kind of wastage, meaning that they just use the water to cool the noodles down, right? So it's just a means of managing the heat from the cooking process to take away the heat. And once that is done, the water is actually discharged into the waste. And as you can imagine, that means a lot of water is being generated, right? This sounds almost identical to how you prepare your white chicken, right? When you want to buy your chicken rice, and you're ordering white chicken, they actually flush the chicken with lots of running water just to cool it down. And the water actually just goes into the waste after that. Right, so what we have done here is we've tackled this for noodle and tofu, but the system doesn't just stop at tofu and noodles, right? It actually goes beyond. And how does it go beyond? Let me give you an example. Now, noodle and tofu doesn't have any salt in the wastewater, so the treatment can be fairly straightforward. Neither is there any oil in the wastewater. Now, we have a client that came to us that was from the seafood industry, right? And in the seafood industry, as you can imagine, there is going to be salt. Now, how do we handle the salt? So that is something that we are actually working with. We are modifying the system to solve that salt recovery or salt rejection to recover the water. Right? And of course, the main issue on food is that the water you recycle shouldn't affect the taste of the food, right? And if it does, then that's an obvious no-no, right? So there's a few criteria that we're looking at. And interestingly enough, this area of recycling the water and F&B is not very widespread. In fact, a lot of the companies just discharge the waste into the waste dump and they don't do any treatment, right? But as you know, the cost of water is going up. So the water tariffs are also increasing. And we have done a little bit of a market we have done a bit of the market survey for you, and you can see that the market survey, what happened? You're seeing my screen, you should see my slide.
Yes.
So I'll just quickly bring you through to the page that we were on. Now, as I mentioned about the tofu, we are looking at other applications into seafood. And of course, beyond seafood, we are also looking into other types of F&B areas. Right? Because as you can imagine, the seafood companies will not be a lot, neither will the tofu. In fact, noodle and tofu companies, you can see the target segments are over there, right? We know that the market has roughly about 40 companies in Singapore. and we are hoping to achieve, well, we hope to sell this to all the companies, but we know that that's not quite practical. So we look at a certain segment of it, right? Now, this is for noodle and tofu. Now, the center, the COI itself, we were actually making a name for ourselves because of our membrane development capabilities. So in the next slide, you actually see one of the membranes that we are putting out into the market. And this is a project that we did under PUB funding, and we have actually concluded the test bed already. And the test bed was done with a 50-meter cube facility that was on the PUB pilot plant site or test bedding site. Right, so we have already patented this membrane, and it is targeted at the UF. Our UF membranes are ready for commercialization and, well, basically scale up and commercialization, whereas the NF still does need a little bit of developmental work, right? So, but UF is ready to go. So I know this is not really meant to sell, but I'm just looking out as well, since we're talking about membranes and water. If there are any companies interested to look at a graphene membrane, right? What's the benefit of this membrane? Now, we have done the performance assessment, and the water production volume is roughly about double that of a commercial UF membrane, right? So we are getting double the water output, and the lifespan of the membranes, it does take a lot longer for it to foul. So we do notice that the fouling is longer. The issue that we have now is that, again, it's on a case-by-case basis. It depends on the water quality at the start. Right, so this is technology that we welcome any inquiries. If you are interested, you can always drop us an email where you will find our contacts later on. Now, I'll move on to the next project that we have done, which was also on membranes. Now, this set of membranes is actually quite an old project. As you can tell from the patent number, the patents were filed in 2013, right? So this was when the center had just about finished one of its first few R&D projects. And at that time, we were targeting desalination, right? We all know desalination, one of the problems with desalination is the high pressure. And the high pressure means you need high energy, right? Because your pumps need to be high energy pumps. So we were looking at using a distillation type membrane to facilitate the recovery of drinking quality water from seawater, right? And of course, in short, that's desalination. So we had a demo plant as well that we placed at the barrage, which was able to recover 5,000 liters per day. And we did develop a portable system, which we were intending for those disaster relief, where we could straight away deploy it on site and help the citizens or the residents of the disaster area have some drinking water. So that's on the desalination. But of course, the main issue with the desalination is that RO now is so cheap. So the energy is, energy is just one of the elements that adds to the cost. So we started to look at other applications of distillation membranes. And two of the applications we found, one was for fertilizer recovery. And you can see here, we did this with chews. Chews is your egg producer, right? So when you produce eggs, you can imagine there's lots of chickens to do that. And with lots of chickens means there's lots of chicken waste as well. All right, so what we did for chews is they had an anaerobic system on their site. And with the anaerobic system that was developing, treating their waste and at the same time producing energy, they wanted to see if they could also capitalize on the effluent that came out from the anaerobic reactor. And this was, of course, your fertilizer. Now, the fertilizer is on the left. That's the effluent, the feed that you see going into our system. And what we were doing here is basically to concentrate that fertilizer and, of course, recover some water in the process. So this was done for chews. Chews had the intention of then selling this as fertilizer to farmers. And this would be organic, if you like, if you can call it that. And also that this would be natural. There's no artificial chemicals going into it. And of course, we did it for electroplating as well. And electroplating basically means your surface finishing industry, right? Now, QNM is just one of the examples here, which we were showing you on nickel salts. The nickel salts is something that is of interest for them to recover. And these are basically valuable metal salts that they are looking, because again, there's value in the recovery. Now, we are also looking at scaling this up because a lot of the electroplating industries tend to be quite small. So we are also looking at developing small systems, right? I know some of the companies here may be thinking, I don't need a big system. I just need a micro system, right? We are able to help and look into customizing a micro system for you as well, right? Now, this comes back down to the cost, of course, because the smaller the systems are, they tend to be a bit less cost efficient, right? Of course, the volume, there's always economies of scale. So this needs to be taken a greater in-depth look at before you embark into micro-sizing such solutions. Now, the next set of solutions that we have are also looking at water treatment, but they're looking at a different type of water, different kind of application. And you can see here, Hock Cheong Automac. Now, Automac here is referring to automatic car wash. And basically, for automatic car washes, you need to have a treatment system in place. That's a requirement. So we developed this for car wash. We also have developed it for laundry recycling, laundry waste. We have approached laundry companies and we have approached dormitory companies, rather the dormitory owners rather. So the dormitory owners are also very keen on this because of the large amount of washing that goes on at the end of the day, right? And that's a lot of water that's being used. And if they could recycle that water, definitely they are doing their part to, well, basically save water. Okay, but beyond saving of water, they can then use it for other purposes, either to recycle it back into the laundry itself or possibly for watering of the plants. Although we all know that watering of plants tends to be relatively low value, right? And of course, that's not the intended purpose. So most of the time, they try to recycle it back to the laundry process, and that's where the value really is. Okay. Now, I have one other example that's a little far off for some of you maybe, right? And this is actually a project we did with Apollo Aquarium where we were developing a soft shell crab detection system. Now, you might ask, what has the crab detection system got to do with water? Well, basically, how do they farm soft shell crabs? This company has a very unique expertise in that they are able to adjust the water quality to trigger the molting of the crabs. And when the crabs molt, that's when they harvest the crabs and present it to you at your dinner table. All right, so that's how you get your soft shell crabs. At least that's the modern, humane way of doing it. The old style of doing it was to take a hammer and to crack the shell of the crab, and that causes the crab to start molting. All right, that's unfortunately not so humane. So Apollo has a expertise on the water side. Now, we had developed a system for them that you can see in the picture. It's actually a set of individual boxes where they are all arranged together side by side. And we actually developed a little robot at the top that goes across the top of all the boxes. And each box it goes over, it will take a picture. And there is a certain AI programming that goes on at the back end that will tell us when the crabs has molted. And the farmers will be notified which block, which floor, in terms of the crab condominiums. We affectionately call these the crab condominiums. All right, so the farmers will be notified which unit is ready for harvest. So that's one of the out-of-the-box solutions. And you will also see that in this example given here, Grundfos is a company that many of you may be very familiar of, right? Because they are one of the largest, if not the largest, pump manufacturer in the world. And Grundfos came to us with their Magna pumps, their series of smart pumps. And they were very keen to deploy the smart pumps into cooling or air conditioning. Right now, Grundfos in Denmark, they don't really need cooling because they only have one hot day every year. So they don't really need cooling for that one day. Right? So as you can imagine, you don't really have an expertise in the air conditioning side. And where better to do it than Singapore, where everybody loves the air conditioning, especially when the weather gets hot. Now, when they came to us, they had a rough idea that it should work, right? Because in Denmark, they actually use the smart pumps for their decentralized heating. Now, they wanted to see if this could also work for cooling. And they came to us with this idea. And what we did for them was we first started off with a simulation, right? Nobody wants to let us touch their systems until we have some degree of confidence that it's not going to cause a breakdown or a stoppage of their operations, right? And that includes Ngee Ann, because later on you will see that one of the sites that we tested it on is one of our Ngee Ann buildings as well, right? But for the first onset, we did the simulation. Simulation gave us very good results. In fact, they showed that we were able to achieve approximately 50% energy savings on the pumping power alone. Right. So when we did that and we presented the results to Grundfos, they were very happy. Happy to the point that they committed their factory and office space for the demo site. Now, when we did this for them, the results came out quite close to our simulation. Okay, and they managed to achieve 55% pumping energy savings. Now, you will see the percentages for chiller and chiller plants are lower, but that's because the total amount of energy is much less. What do I mean? Let me show you in the next example where the deployment site is in Ngee Ann. Now, this deployment site is actually open for visits. We allow Grundfos to bring their prospective clients to take a look at the system to have a better understanding how that system works. Now, the distributed pumping system is not really invented by Grundfos. It has been published before in all the professional journals and publications, but no one has actually managed to deploy it in a successful commercial scale. And we dare say that we are probably the first, together with Grundfos, to have a commercial application and deployment of the distributed pumping system. And this is really just pushing water through the whole system, right? Because you are looking at central cooled systems where you are using chilled water to cool down the building. And in our second deployment site, the first site in the Grundfos own building, it's a very low story office and factory setup. It's only 2 stories. So in 2 stories, the effect isn't really seen because the pumping in such buildings is because of the height of the buildings. And if you only have a 2-story building, there's not much head that you need to pump up, right? Whereas if you have an 8-story, well, 8-story is also not ideal. They were hoping for a 30-story or a 40-story building. But again, without evidence, no building owner will allow us to deploy this at the particular sites itself. So we took a risk. We managed to convince our Ngee Ann estates that this is a good system. And because we have done the assessment ourselves, we were quite confident it will also work. And true enough, you can see the values on the screen. Our baseline, we saved approximately 51%. So it's quite close to the 55 and the 50% that we calculated from the simulation studies. And also the same for the chiller savings as well. We had a 16% chiller savings. Now, I mentioned earlier that the quantum was quite different. So if you take a look at the post-retrofit savings, it's 1,000 kilowatts, right? If I round it down, it's 1,000 kilowatts. That's for your pump saving. But if you look at your chiller savings, it's 200, well, it's approximately 40,000. Well, okay, sorry, I did not deduct the total. It's about 1,200 savings from the baseline. And for the chiller, we are saving about 40 kilowatts. So this is a huge amount, much more than your pump savings. So why do you think that there is a chiller saving, right? Very simply put, if you are pumping less, you need to chill less, right? So because you are chilling less, your chiller plant will save energy. So this is the general guide when we advise our clients why the savings is so high. Now, these findings has been verified by BCA engineers. And BCA has come down to assess our building as well. And we are able to conclude that, yes, the buildings, this is a real savings. The results are not fabricated, in case you are wondering, right? We are a government agency, so we have no purpose to fabricate the results. And of course, we also want to show our bid for climate change. And over here, because of the energy savings, we are able to save 62 tons of CO2 emission per year. Right, so this is for the digital pumping system. Now, I also want to stretch your imagination a little bit, right? And this is where we are very good at doing, right? Because we are a center of innovation. So allow me to stretch your imagination a little bit and to let you have some sense that this distributed pumping system doesn't just have to work with chilled water cooling systems, right? Now, any system that requires a lot of pumping, and this is consistent and regular pumping, could make do with this particular system as well. And that could be in aquaculture, for example, where you're moving a lot of water. It could be in maybe decentralized provision of water, perhaps, right? Where you instead of having one massive pump to push everything through, you have what we call here the distributed pumping system. Now, I have to apologize. I know I did not explain in detail about how this system works. So allow me to just take some of your time to give you a very simple understanding why we call it distributed pumping system. Now, in your typical chilled water system, you have one massive primary pump at the bottom here, right? For ease of explanation, I'll just say at the bottom, this primary pump has to push the chilled water all the way to the top floor of your building. So you can imagine the amount of head that your pump has to overcome. Now, when we change the system and retrofit it to the distributed pumping system, we do not need to do a massive overhaul. We only replace the primary pumps. In fact, we downsize your primary pumps. And to give you an idea of how much we downsize, in Ngee Ann, when we retrofitted the system, we changed the primary pump from a 4.5 horsepower or kilo, I can't remember the unit now, but I believe it's 4.5 kilowatt pump. We downsized it to, or megawatt. Forgive me if the numbers are wrong. I'm not an engineer, so that could be. But we downsized it from 4.5 to 1.5, right? So it's a threefold reduction in the energy consumption. Now, even though we downsized it 3 times, we now have distributed pumps, right? And hence the name distributed pumping system. We have pumps that are decentralized at every level. Now, why we have it at every level is because we are now no longer just pushing water. We are pushing as well as drawing water, right? So that means the head that you need to overcome is a lot less. Now, that's all the technicalities I will go into, and that's also probably the limit of my understanding. Now, because we are reducing the head that you need to overcome, energy savings can be achieved there, right? And of course, all of these pumps are smart pumps, so they communicate to one another. And to the end users on the ground that experience the coolness from the chilled water system, what it means is that you no longer have to wait half an hour or 1 hour to feel the cooling effect. The cooling effect will be almost instantaneous, at least at the blower side and at the chiller side, right? So this is the efficiency of such a system working in practicality. Now I will move on to the next item, which is again something some of you may have heard us talk about before. It's using membranes, but using membranes in a application that is unlike what you would imagine, right? And again, this is for air conditioning, because as you can tell from distributed pumping systems and the other earlier projects, we do have expertise in air conditioning. So my aircon experts and my membrane experts got together and decided, why don't we look at using membranes in providing cooling? Right. So over here, this is, by the way, a work in progress. And we are still open to companies that are interested to co-collaborate with us to develop this. Now, we are working on this membrane reactive cooler for a while. And what we are able to do is we have done a side-by-side comparison with an actual chilled water system, right? So you can see the cooling tower in the bottom right corner. Now, this cooling tower system, why we want to do a side-by-side is to show the real energy savings and the real benefit of the system. Okay, now this is still a work in progress, and we are still keen to look at potential partners that want to come in, right? We do face some challenges, but that is always the case when we do scaling up. Things that are done in the lab scale, because it is small, doesn't really show some of the problems that you get with the size, right? So we are looking for potential interested parties to collaborate with us on. Now, aside from aircon, now we move into an area that is also quite close to aircon, indoor air quality. And this is something most of you will be very familiar with now, especially with everybody having to wear face masks when they go to our office, when they go to work, right? Now, this is a technology that we developed. Essentially, it actually really wasn't for indoor air quality. It was really looking at decontamination and detoxification, right? So if you look at the slide, you can see some information there about the filtration efficiency, which is a given, because if you develop a filter, it has to have some filtration efficiency. But beyond that, we actually imbued in additional functionalities like detoxification, as well as decontamination, right? And over here, we don't call it decontamination. We actually use the term bacterial disinfection. Why do I say that? Is because the bacteria doesn't just get trapped on the surface. It is not a physical trap. This is a physical killing effect, right? So when it gets onto the surface actually kills the bacteria. And this is the same for the chemicals as well. The chemicals do not just bind to the membranes. The chemicals are actively being broken down by the functional membrane surface, right? So this is the main difference. And what this means is that instead of having to dispose of this as chemical waste or biological waste, it can actually be disposed in the regular waste. Okay, so there are some benefits here. And of course, below, we show some ways that this can be applied to. You can be in face masks, which is currently the current interest. One of our licensee that is potentially talking to us is looking at putting this into face masks and surgical masks. We also have another interested party looking at car filters, right? So we're looking at, again, different applications for the same technology. And one of the benefits of this technology is the reduced pressure drop. Now, I mentioned earlier in water, we have the water waste energy nexus. Now, same for this membrane as well. Because we have a lower pressure drop, we also experience energy savings. You need less energy to push the air through, right? So that's where the energy savings can be obtained. So again, if you stretch the applications a little bit, you can look at reducing the energy requirement for equipments that need to have certain filtration levels. All right, so that's all the projects that I'll be showing. And I thought nothing better than to summarize in brief, just a very simple snapshot of the kind of support that we can provide to companies. Why I started with the projects first is because it's always easy to give you an idea of what we do through the projects, rather than to just tell you the different services that we provide. Over here, you will see there are 4 different tiers, starting from tier 1 all the way to tier 4. The tiers, if you like, also correlates to the cost. And at tier 1, we have what we call a facility use service. This is where we have certain equipments that we are actually opening up to companies, clients, as startups to come in and use on a rental basis, right? And you can rent it for a fairly low cost. It covers quite a wide range of equipment. You can use multiple equipment at the same time for a flat rate. Our rate is just charged on a 4-hourly block. So it's a flat rate per 4-hour block and open to all the equipments that are on the list. Of course, there are certain equipments that we do not open up, things like our scanning electron microscope that we will have to control because of the nature of the equipment and the testing. And of course, we do also provide training under the facility use. So all companies that come to us to engage onto this facility use service, we will provide training with a certification so that we can qualify your ability to run and operate the machine. And of course, in tier 2, that's a fixed service. So when we talk about facility use, generally we are targeting companies that have deep technical expertise, right? So it could be your deep tech startups or basically SMEs that already have experts. So if you have your experts, you don't actually need to pay us for the manpower. You only just need the equipment, right? So that will work for you. And if you are short of manpower or you don't have the expertise, you can then look at tier 2, right? So tier 2, we are providing a fixed service package. And what this means here is we will give you a certain number of tests, right? Let's say you want to identify if your membrane is fouling or not. We can provide membrane post-mortem service, right? That's a fixed package price because we provide certain services that are all covered under a certain fixed price. And the price has been fixed because we want to keep it affordable, right? And that's why we call it a fixed service. And of course, if you need a more customized approach, then we can move on to consultancy projects. And over here, consultancy projects will include all sorts of customization. If you need things that are out of the standard, right, out of the norm, you need a bit more unique modifications, we will look at consultancy projects. And of course, if you also want to develop new IP, we can look at contract research as well, right? I do advise that companies should come to us on smaller proof of concept projects first before they embark onto a large contract research, because contract research generally goes into very high cost and it's a long drawn process, right? So these are the 4 tiers that we offer. And that's pretty much all that I'm going to share today. And what you see on this slide is some of the partners that we've worked with. Some names are big names to small names, overseas partners, local partners. We have quite a good mix. And sometimes, one other service that we provide that is not quite so evident is what we also call matchmaking. You will see Kimberly-Clark at the bottom left, right? When we engaged Kimberly-Clark, they had a project which they put up for an innovation award under the Singapore Chamber of Commerce. And in this particular project, they had a waste material that they produced from their wet wipes manufacturing process. And this material they had to dispose, which means that they had to pay for the disposal. They came to us to see what they could do with this waste. And we did a simple feasibility study for them to look at the calorific value, look at the absorption of the materials. And we were able to matchmake this company, Kimberly-Clark, to a local toxic waste treatment company who was actually using sawdust to absorb the toxic waste before they incinerate. Now, what we did was we suggested to the local company to use Kimberly-Clark's wet wipe trimmings. It's of course not wet, it's dry. Before they add the liquid, it's dry, right? So it's we call it the trimmings. So we suggested to the company to use the trimmings to absorb the toxic waste. And when they did the study, we found that they actually used 5 times less sawdust, well, in terms of weight per weight. So where they would have normally used 1 ton of sawdust to treat the waste, they now needed only 200 kg of the trimmings to treat the waste. And on top of that, the calorific value of the trimmings was very high, right? It was something like 6,000 calories, 6,000 joules, if I remember correctly, as opposed to sawdust, which is about 3,000. So they were able to burn and obtain more energy from the burning process. And of course, there's another side benefit. When we tested the ash content of the trimmings, it was virtually zero. So after incineration, there was virtually no ash left. So they had even less to worry about after the burning process. So this was you could call it a match made in heaven, right? And it happened because we were working with both companies on separate projects, right? And it just so happened that Kimberly-Clark came to us and we could see an application of their waste material into another company's process. And that's how we matchmake the two companies. And they are now selling their trimmings to the local company. So Kimberly-Clark is now able to turn what was an expense into another product, right? So just a very simple example of some of the companies that we work with where it doesn't have to be major development of IP, right? It could be just a very simple feasibility study that will materialize into a developmental or, a nice matchmaking kind of a project. Yeah, so that's all that I have. Now, if you are keen, you can always connect with us on LinkedIn. You can also drop us email inquiries. We are regularly going to have some tech experts kind of a forum where you can chat with our experts and, just toss out some of the questions you may have. Sometimes you don't need to engage us on the project all the time to get answers to everything, right? We do entertain a lot of requests from various sources. So do connect with us and let us know what your needs are. All right, so thank you very much. And back to Vivian.
Thank you, Dr. Jason Tang, for your invaluable sharing. May we now invite Mr. Pung from Firmbase to share with us on their tech development with EWTCOI. Mr. Pung, over to you.
Thank you, Vivian. Okay, can everybody see my slides?
Yes, thank you.
Okay, good. Thank you. Well, good afternoon, everybody. Thank you for taking the time to attend this webinar. I also like to thank SWA and EWTCOI for inviting me to talk this session. Before I start the talk, I'd like to wish everyone, your family and your loved ones well during this difficult time. I'm C T Pung, the founder of Firmbase Private Limited, and today I'd like to share with you my experience of collaborating with EWTCOI developing super hydrophilic water filtration membrane. Okay, in today's talk, I will give two examples of collaboration on membrane technology scale-up with EWTCOI, and to share with you the key learnings in the process. Before I go into detail, give me 1 minute to introduce Firmbase. Firmbase is a Singapore company established in 2011 after I worked in a multinational chemical company for and decided to answer my calling to venture out to focus on solutions for a sustainable economy. I have set the mission of Firmbase to explore development opportunities in advanced materials to meet the growing needs of water, energy, and infrastructure. So how did we get started to collaborate with EWTCOI? Well, way back in 2016, as I scanned the horizon for new polymers we use in water and energy application, I found some dendritic polymers that are super hydrophilic, which can greatly enhance the energy filing performance of water filtration membrane. This performance in turn will result in energy saving, higher water flux, and lower operating downtimes and membrane system. However, no one has used dendritic polymer for commercial membranes before, and my business is in chemicals. It's not in water treatment. So there were many difficulties that we were facing. For a start, many market unknowns. Who do we sell our polymer to? We sell it as an additive to a mainstream polymer producer. We sell our polymer to the membrane producers, or even do we actually make membrane fibers for system integrators? We lack the technical expertise and the resources in terms of equipment and facility to conduct the necessary application tests and evaluation to enter the water membrane markets with our polymer technology. We are also concerned with IP-related issues as we lack the understanding on IP protection in the membrane market space to protect any new technology that we may develop or we might infringe. I expected that it would take 2 to 4 years and significant investment to take this technology from concept to market. We needed external expertise and resources. And I went around Singapore and found EWTCOI that has the membrane technology expertise, resources, and a focus on applied research and scale-up. So this started our journey with EWTCOI. So the first application or collaboration that we have with EWTCOI was on the application of dendritic polymer on hydrophilic membranes. This resulted in a proprietary polymer, is PVDF ultrafiltration membrane with improved anti-fouling and greater than 25% lower operating pressure, resulting in reduced operating energy costs. The whole project is in 3 phases. In the first phase is proof of concept. During this phase, we determine the appropriate dendritic polymer that can enhance the anti-fouling performance of the membrane. We were able to demonstrate against a standard PVDF PVP membrane that with the addition of the dendritic polymer, that it has better anti-fouling, and that the dendritic polymer does not leach out over time like other hydrophilic additives, and that the membrane actually has lower surface contact angle and more even pore size. We are satisfied with the improved performance by the dendritic polymer and decided to move into the next phase of evaluating a prototype membrane. And this is the second phase, whereby it's a validation in pilot environment. We fabricated the dendritic polymer enhanced PVDF ultrafiltration membrane module to validate in a pilot plant. It involved running secondary effluent water through the membrane module at 50 LMH continuously for 120 hours. This phase also compared performance of the dendritic polymer enhanced membrane against a leading commercial membrane. The comparison results were very promising. We observed that the dendritic polymer enhanced membrane operates at a lower P&P, which means it results also in low operating pressure. And we also observed a higher filtration efficiency. And what this also means is that it needs lesser backwash and thus reduce membrane downtime. We were excited with the results, and this greatly helped us in the marketing of our polymer. We also found that the membrane market can be segmented into different water treatment segments and value chain. We then decided to strengthen our membrane know-how with potential to serve the more specialized water treatment segments with our unique polymer technology. And now we are into phase 3, which is scale-up phase, which is to demonstrate the polymer and membrane technology on a PVDF ultrafiltration membrane at production scale. And before the end of the year, we will have membrane modules for customer trial. So do let me know if you have interest to evaluate our polymer or our membrane. Our second collaboration with EWTCOI is on technology licensing. As firm-based understand more about the membrane technology and the market, we explore to extend our product. This is whereby we have discussions with EWTCOI on their oil-water membrane separation technology that handles 10 times higher concentration of oil for oil-water separation. We evaluated and determined that firm-based polymer capabilities and expertise will enable the scale-up of EWTCOI's polymer for the oil-water membrane and decided to license their technology. After licensing, firm-based and EWTCOI continue to have technical exchanges, and with EWTCOI's providing advice when necessary for firm-based to develop the polymer manufacturing process. We have developed the process to produce the polymer, and will soon proceed with customer trial of the polymer in oil-water separation membranes. Again, do let me know if you have interest in evaluating our polymer. Coming to share learning. As an SME, firm base is very limited by resources and funding, and collaboration has always been key enabler for us bring new products and also in our new expansion. And here are the key learnings which I'd like to share with everybody. That's through the collaboration with EWTCOI. And I believe this can apply basically not just with EWTCOI, but with any other collaboration as well. In Singapore, I think there is a very good innovation collaboration framework that is already in place for SMEs innovation advancement with the government support and institution or COIs. However, this does not come free, nor does the collaborations framework come looking for us. We have to learn and we have to work on leveraging this collaboration framework. Secondly, as we set up any collaboration, first and foremost, we need to understand and agree with the goals, objective, and deliverables that the collaboration aims to deliver. We cannot leave it to chance or to make assumptions. Otherwise, the collaboration may end up in disputes and even fails. And thirdly, we must know our strengths and weaknesses and know what and why we are taking on any collaboration. Be it a lack of expertise, or a lack of resources, or a need for speed. We have to know why we are taking on the collaboration, so that the collaboration with the institution or the COI will be the catalyst or enabler for success. Fourthly, any collaboration project will take time. and we will learn new things along the way. We will have unforeseen barriers. We will have new challenges. Market will change, and there will be alternatives. We must be prepared to make adjustments along the way. And lastly, commitment. Collaboration is a joint effort. It's not an assignment where we throw effort. It must be fully committed. Sorry, there's something that came on my screen. We must be fully committed and have regular reviews. We must have the willingness to listen and to input, and be prepared to make decisions on direction. I hope my experience and learning here will provide you with some insights of how SMEs can utilize this established innovation collaboration frame of the industry, institution, and governments. In summary, firm-based and EWTCOI have pursued technology breakthrough in energy-saving and highly efficient water membrane with advanced polymer technology. And we have done this through collaboration with synergy. Before I end, a little advertising. Given firm-based membrane technology advancement, firm-based is seeking strategic partners, collaborate on technology, manufacturing, and marketing. And I welcome any interest and inquiry. Last but not least, I'd like to give my sincere and special thanks to Enterprise Singapore for their continuous support and assistance. With this, thank you, and I welcome your questions and pointers. And you can see my email contact below. And during this pandemic, be safe, healthy.
Okay, so at this point, I'll just jump in and moderate what we would have now as a brief Q&A session. So we will probably start with going through some of the questions that I see in the chat. By the way, if any of you has any questions as well, feel free to drop your questions into the chat so we can read out for whoever's around and run through some of the answers that we may have for the questions. Now, the first question I saw was from Zhang Hao from Curita, right? Asking about a better solution for sulfate removal, and the sulfate level is from 200 to 400 ppm. Well, it really depends on what you have already tried, right? We do understand that the size is pretty small, right? So there are certain limitations. Now, we are aware of technologies like electrochemical coagulation, where you could potentially use that to agglomerate all your sulfate so that it's easier for removal. But again, there are certain, I have to admit, I'm not the technical person. So my technical guys are actually also in the meeting as well. So I do welcome them to jump in and help to address this issue. But for all means and purposes, I would say that an ion exchange may actually work for you. At the end of the day, you would need to regenerate the membranes, right? Because if you're looking at ion exchange, it doesn't work forever, right? You got to regenerate it or reactivate the ion exchange membrane. So there is going to be certain requirements. Now, electrochemical is something that is also available, but it's not readily deployed in Singapore, right? I can't say if it will work for you, but it's something that we will need to assess on a case-by-case basis, right? So what I can do is we can take your question and take a look at what's already available. And if you already have certain things that you have tried, do let us know, and we can come back to you if there's something that's better, right? We do understand that there are certain limitations to the current technologies for treatment. So say, for example, your HF, right? We all know HF is very hard to treat. And right now you have a lot of innovation challenges going out, asking for technologies that can handle HF, which is a very, very difficult thing to handle. So sulfate may be a little bit easier because it's quite a common chemical. So let me pass this question to my experts, and I'll welcome any of them to jump in if they have anything to add. Barring which, if there's nothing to add, then we will have to take this back and take a look at what's already available in the industry, right? The first step we always take is always to look at what's already commercially available, because we don't want to reinvent the wheel if there's something that's there. And we also understand that there's a lot of cost when it comes to development. So taking something that is already there is the first cut that we always do, right? I know, Kurita, you are a water company, so most likely you have already looked at the technologies that are out there. But we can look at developmental technologies as well. And sometimes it's a matter of testing for your particular wastewater, whether it works, because sometimes it's not just about the sulfate level, but what other contaminants you have in your wastewater, right? So that's pretty much about all I can say, looking at the limited information that we have. Maybe I just do a quick check with my experts. Any of my guys want to comment about this question as well?
Hi, I'm Chun Heng. Yeah, I'm in the membrane team of EWTCOI. Maybe I can share that my point of view is maybe you can consider nanofiltration, because nanofiltration typically has a more than 90% rejection of sulfate. So probably that will be a suitable technology.
Yeah. Okay. So you've heard from my colleague Chun Heng. Now, it may not be the solution. So I would suggest that we could take this as a separate discussion, and either through email or face-to-face or online meeting, whichever would be the better case for discussing this issue. Right. Now, I hope that answers the first question. So I will go on to the second question that I see. And the second question is, there are quite a number of recycling projects going on with the membrane process. The TDS, including some ions, sulfate, chloride, COD, are being concentrated, which cannot meet PUB discharge. What is the current measure to solve this issue? Well, it depends on whether the waste that is generated, is it still liquid, right? If it's still liquid and it has to be discharged, chances are you have to get a certified waste contractor to dispose of it for you, rather than to put it into the PUB system. I would imagine that would be, without knowing what's the waste that is being discharged, I would say that's about what I can suggest. We have, most of the companies that we engage for this is really FMB. So FMB has always been discharging it into the sewers, and even if they cannot meet, they would still discharge into the sewers and just pay the water tariffs for it. So this is the current system, right? And there are other FMB partners that we know of where the waste is more solid, right? So they do engage a contractor to cut it away. And generally it is either incinerated or it is sent overseas to be converted into animal feed if it's FMB, or if it's something else, then it's probably going to be incinerated. Right. So I hope that sort of answers the question, because this thing about discharge, right? We do know a lot of companies just dilute, right? Which is quite ironic, because rather than to pay for the excess discharge, they will dilute it with PUB water and discharge. Yeah, I mean, it's not advisable because that's not what PUB wants people to do, but we do see it on the ground. Okay, I will move on to the next question. And this is on the graphene membrane that I showed earlier, right? This is from Rama Krishna. Singapore working towards lower water footprint, lower carbon footprint, and graphene as a product has a very heavy water footprint. Membranes with graphene might show better performance, but how about leaching, disposal, and cost? So at this point, I would like to welcome my colleague Bhuvana, who is with us. She is actually the project lead on this technology. And I will get her to answer this question. Bhuvana?
Hi, hello everyone. Can you all hear me?
Yes, we can hear you.
Okay. Yes, we agree that the carbon footprint is also important, but I would like to answer your question on the leaching first. For this product, actually, we have chemically grafted the graphene oxide to the polymer backbone. So it won't leach from the membrane. And the cost, yes, we also agree the cost of the graphene oxide is very high. And we are also looking into that. But for our membranes, we are not using fully graphene oxide. We are just making some a grafted functionalized graphene oxide with the polymer and then using it as a percentage to the commercially available polymers like PES and PVDF. So it is not so much, but we are also looking into the cost and how to reduce that. Yeah.
Okay, so I thought to add a little bit to the water footprint. Here, I am not quite sure what you mean by lower water footprint. We actually produced we can produce our own GO, and we have a pattern on producing our own GO where we actually use a lot less solvents, and it's not as hazardous as the current graphene oxide production method. So that may be what you're looking at in terms of the graphene oxide production, I hope. Yeah, so I don't have a context as to what is this question referring to. So I would imagine you're looking at graphene oxide production, right? Because that's using a lot of chemicals as well. And the process of that, you've got to treat all the byproducts. So that was also a problem that we identified at the start of the project, right? Which was why the outcome of the project was not just to look at the membrane development, but also at how can we provide a more environmentally friendly graphene oxide for the membranes. So that's part of the patterns that we developed it's a suite of patterns actually. We had one on the graphene oxide production, one of the UF membrane, and another one on the NF coating. Okay, so let's see if there are any more questions. Okay, I have a question here for CT. CT is what we call Mr. Pung because he likes us to call him by CT. So CT has a question, and the question is, what are the training and education aspects firm-based can offer?
Well, I think these questions refer to my slides on the collaboration with EWTCOI on the dendritic polymer hydrophilic membrane during the scale-up phase. Actually, what I'm trying to mean in that slide is that as part of collaboration and in the scale-up phase, part of agreement which we have with EWTCOI is the technology transfer from EWTCOI to firm-based. So as you know, firm-based, basically we are more in the chemicals area, and we are very, very new to the water industry and membrane technology. So part of the agreement that we have with EWTCOI for the scale-up phase was, to provide us some education, training on membrane fabrications, and also in the operating of a production membrane spinning facility. I hope I do answer that question. Anything else you want to chip in, Jason?
Sure. Yeah, so I thought I'd also like to chip in here. Now, the EWTCOI, we are moving also into a phase where we are developing short courses for industry, right? So if there is a demand for learning on how to develop membranes or scaling up of membranes, or even anything related to that, we could, if there's sufficient demand, we might actually want to put up a short course and conduct this for industry-wide, right? And this is something that we are going into because we recognize that when we develop technologies, we also need companies that have the expertise to manage those technologies, right? Because it doesn't make sense to develop it and at the end of the day, nobody knows how to operate it or even to take over the technology, right? So this is an area that we are recognizing as quite important. We then also help and support Singapore's interest to develop deepening of skills, right, under the Skills Future program. So if we conduct a course, you will be right to also assume that it will probably fall under the Skills Future, which means that citizens and PR will have a highly subsidized rate, right? And just to add on that point, you saw earlier my slides on the distributed pumping system. Now, we are actually launching a short course on how to design for such distributed pumping systems, right? And this short course is going to be done in October. For those of you that are interested, we can also send out the details to you. Now, this is a short course that will teach people on how to size the system and to design the system for your application. Of course, for our training purposes, we are using the air conditioning system as an example, right? If you do have other applications, it is just about understanding the concepts, how to do the calculation, the sizing, and that will work for your respective application, right? So that's one of the examples how projects with companies can also materialize into training opportunities. And this will help the greater community. I think it's not just a unique requirement for one company to have certain degree of training, right? I would imagine this would be the same for quite a number of companies in the water industry. Yeah. So that's just my 2 cents to add on to Mr. Pang's or CT's reply. Now, CT, there's also another question for you. And here the question is asking about the dendritic polymer enhanced membrane, right? You mentioned in your slide that it has a better water flux efficiency compared to commercial membrane. Is there any figures you can give us to give us a sense of how much better?
Okay. Right. To answer this question, right, as I mentioned, this was actually done in a pilot water treatment plant. And, it was basically running the membranes modules, right? The dendritic polymer enhanced module and then the commercial module, right? Mm-hmm. And running them, let's say, 120 hours at a consistent 50 LMH water flow. Okay, and with that, basically what we observe is that, say, for the commercial membrane, the flux, sorry, the PWP, right? The clean water flux was around 380 LMH per bar. Okay? Mm-hmm. And for the dendritic polymer enhanced membrane is 405 LMH per bar. That's basically about 7% higher than the commercial membrane. And I say both are PVDF-based ultrafiltration membrane models. Okay, and the resultant permit water basically are the same. And I say, the same for water condition and same flow condition. Okay, and I'm saying that probably if we would test it in different water, we probably get different results, and this is why we basically from so-called pilot scale, we are basically doing so-called production scale. Right? And that's why I also welcome any of you who may have interest to test our polymers or to test our.
Okay, thank you, CT. So I think this is always a tricky question to answer because it really depends on what is the feed that you're providing into the system, right? And the different feed will then give you different efficiencies. And we also try not to have a feed that is too synthetic, right? I think with a synthetic feed, generally your results are always very good, right? So with CT's project, I believe we used not synthetic feed, but we used a secondary effluent, right? If I'm not wrong, CT?
Yeah, yes.
Yeah. So this was the real effluent, not a synthetic effluent that we artificially developed, right? So we wanted to keep results true to the actual performance itself. Yeah. Any other questions? Maybe there isn't any more in the chat, but if you have, you could always unmute and just talk over the meeting.
Dr. Tang, we are slightly overrunning, so
Sure.
I guess we can wrap up the Q&A segment.
Okay, I think that's fine. Yeah, it looks like, if you do have any questions, my last parting thoughts would be just to drop us an email. You have CT's contact, and if you connected with us on LinkedIn, you can also drop us an email. Otherwise, Vivian will actually show you one of the slides where the contacts are indicated. Right, Vivian?
Thank you, Dr. Tang.
All right.
Yes. If you have further questions on the webinar itself, please contact the Singapore Water Association office. But you have any further queries or questions, please contact Dr. Tang or his team at EWTCOI, Ngee Polytechnic. And please complete a post-event survey, which upon your return will forward the recording and tag to you. Thank you all for attending today's webinar. We look forward to seeing you in our next coming webinars on the 22nd September, Unlocking the Potential of Wastewater with the Royal Danish Embassy. And also on the 6th October with PUB BIM, that is BIM e-Checker Initiative. Thank you all for coming today. Thank you, speakers. Thank you, Dr. Tang. Thank you, Mr. Pung.